Okay, this is a revision for oxidation numbers. We're looking at the rules, the algebraic method really quickly, but then I'd like you to use working around the formula method. And understanding that oxidation numbers are used to identify which substance has undergone reduction or oxidation, particularly if it's a covalent molecule. As you can see, if we react iron, it's easy to see that the iron metal has lost its electrons and become ions, and then something here has gained electrons to become hydroxide ions. So there's a reduction reaction happened here. But if you were asked which one of these things has undergone reduction, it's not so obvious. Has the hydrogen undergone reduction? This oxygen, that oxygen, doesn't matter which one. Alright, so the thing is that reactions with molecules don't literally involve a loss or gain of electrons. It's a balance of charges within the molecule due to its different electronegativities. So they're sharing, they're always sharing, so it's hard to know by looking at the molecule formula if it's lost or gained when it becomes a new molecule. So just remember they're artificial numbers, and they don't literally lose or gain to become ions. So the oxidation numbers, the first are the rules. The free elements have an oxidation number of 0. So by free, I mean it's not bonded to, it's not a compound. So pure sodium metal, or magnesium or solid metal, or non-metals that aren't bound to anything else. So then sharing electrons with another chlorine or another oxygen or another hydrogen, so they're sharing totally equally. Then they have an oxidation number of 0. We write the oxidation numbers directly above the element symbol, not off to the side. So ions have an oxidation number that's the same as their charge. So their charge, you write the charge 2 plus, but the oxidation number is plus 2. And to write it directly above, not off to the side like an ion. So oxygen in a compound is normally -2, except for these ones where it's -1. This one is useful sometimes, hydrogen peroxide. Hydrogen is normally +1. It's got 1 electron to lose, so it loses it, becomes +1. Except if it's with a non-metal. If it's with a metal, then it acts as if it's a non-metal. So the metal itself would be a positive, and then it would be negative. Okay. If your compound is neutral, if it has no charge overall, then all the oxidation numbers for a compound have to add up to 0. So in this case, lithium oxide, it's a salt. We know we actually could work out the oxidation numbers without having to do this, because we know that lithium is 1 plus, so its oxidation number must be +1. And oxygen is 2 minus, it's an ion, metal and non-metal, so it's an ion. It's 2 minus, so its oxidation number would be -2. So we don't actually have to work anything out, but I'll use this to show you how to work it out if you had to. When you've got two elements, you must know the oxidation number of one of them, and oxygen is, like we said previously, its oxidation number is normally -2 in a compound. So if we write in the -2, then we can work out the lithium. So algebraically, if you take that over the other side, it's a negative on that side, it becomes a positive on this side. You've got 2 of them, so if we divide that by 2, then each one of them is 1 plus, which is what we knew anyway, that lithium has a 1 plus charge, so its oxidation number must be +1. So you can do it algebraically if you want, rearrange the equation to find the one that's missing. Or I'd like you to do basically exactly the same as this, but do it around here. So oxidation numbers are always on the top, directly above, and just do your working out underneath. So it's -2 for oxygen, there's only one of them, so your total negatives are -2. These have to be equal because there's no charge overall. So if you've got two negatives, you have to have two positives. These two positives are broken up between the two lithiums, so each lithium is +1. So these are the oxidation numbers. So if you just work your way around, you can work them out. Do exactly this around your formula. Okay, so magnesium, another salt, because you know it already. Really, this is -1. This is 2 plus charge, so +2 for the oxidation number. One of them you would have to know if you're working it out algebraically. So in this case, I've assumed that you know the chlorine. So the oxidation number for chlorine would be -1. You've got two of them, so -2. If you take it over the other side, it's +2. You've only got one magnesium, so it's +2. If we do it around the formula, -2, oxidation number is the same as the charge. Do the total. Underneath you've got two of them, so each of them is -1, then overall you've got -2. There's no charge, there was for the whole thing, so you need the same number of positives as negatives. You've only got one of them, so it must be +2. So just work your way around. Oxidation numbers on the top, do your working out on the bottom. Okay, this one, we have to know one of them, so we'll say oxygen. So oxygen is -2 in a compound. Underneath we've only got one, so it's -2. There was no charge, so it has to be +2. We have two of them, so +2 divided by 2 is +1. Alright, I should have this in brackets, so if you have an ion like this, then this whole thing has a charge of -2. So we can work it out individually. Oxygen is the one that we know. We know that oxygen is -2. I've done it algebraically first. We know that oxygen is -2. So we'll fill this in first. Algebraically, the whole thing has a 2 negative charge this time, not neutral. Okay, all the other ones we've done, there hasn't been a charge, but this time they all have to add up so that there is a charge. Okay, so we start with oxygen. Oxygen's -2. We've got 3 of them, so altogether we've got -6. Take it over the other side, it becomes +6, and -2 is +4. And we only have one carbon, so it's +4. So the oxidation number of carbon in this is +4. If we did it around here, -2, we've got 3 of them, -6. You need some number that you add to -6 so that you have 2 negatives left over. So the number that you add would be +4. You've only got one carbon, so the oxidation number for carbon is +4. Okay, fluorine is most electronegative. So when you put it with oxygen, it becomes the negative. Have a go at these. Pause the video. I'll give you the answers right now. Okay. So if you work our way around, -2, only one of them. Need the same, so +2, so +2. This one, -2, we've got 4 of them, so -2 4 times is -8. Have I done it around here? No, I haven't. Sorry, I should have done it around this. And this arrow is driving me insane. There it is. -2. 4 of them, -8. So this will be -8. There's no charge overall, so you have to have +8. We've got 2 of them, so +8 divided by 2 is +4. Okay, you've got 3 here, so you need to know 2 of them. You know the hydrogen. Hydrogen's always +1, and you know the oxygen. So -2, and you've got 3 of them, -6, +1, there's only one of them, so you've got +1. I almost should pause this. So you've got +1 and -6. So if you add +1 and -6 together, you get -5. So we need another positive to get rid of that -5. So this has to be +5. So the oxidation number, because you've only got one of them, is +5. This is a bit irritating. I'll talk you through. If you get stuck, you'll have to come and ask me. So we do the oxygen, -2, you've got 5 of them, -10. no charge, so you need plus 10. You've got 2 of them, plus 10 divided by 2 is plus 5. Okay, you've got these two. Which one do you know? You know the hydrogen, sorry. It's plus, okay, this is a bit weird, this one. Hydrogen, when it's with a non-metal, acts like a metal. It loses its electrons. So it would become positive. So I've lost my arrow again. This is plus 1. You've got 3 of them, plus 3. No charge overall. So you need minus 3. There's only one of them, so it's minus 3. Okay. Have I got any more? Yep. Okay. So these two you know oxygen, and this is an ion. This is metal and a non-metal, so this is an ion. So the charge on magnesium is 2 plus, so the oxidation number is plus 2. We only have one of them, so this is plus 2, and you know the oxygen. Oxygen is minus 2, you have 4 of them, so it's minus 8. So we've got plus 2, minus 8. If you add them together, you get minus 6. So you need a positive that cancels that out because there's no charge altogether. So you need plus 6. There's only one of them. So it's plus 6. Okay, I did it separately, apparently. Alright, so the rule, if the oxidation number goes, and here we have, if you burn carbon with oxygen, you make carbon dioxide. Minus 2, minus 4, plus 4, plus 4. Okay, so the oxidation number has gone from, it's a neutral compound, just carbon, 0, up to plus 4. So if it becomes positive, it means it's lost negatives. If it loses negative stuff, oxidation is the loss, reduction is the gain. So it's lost electrons, so it's oxidation. Okay, oxidation number's gone up, it's become more positive, it's oxidized. This one's probably makes a lot more sense with words. If oxidation number comes down, it's gained negative electrons, it's been reduced. Okay, so oxygen, pure oxygen, has gone from 0 to minus 2.